Hello everyone and welcome to another session. So what we're going to do today is structured analysis on a tapered wing. Okay, so we are going to try to learn some structural data about a loaded aircraft wing. So we'll just take a normal aerofoil and we'll just try to analyze it over some particular length of a wing. Okay, so for the first we will require an ANSYS workbench and we'll require geometry. Now for the geometry again I'm using design modeler. You can use SpaceClaim if you want, or since it's a wing you can import it from other design softwares as well. That's up to you how you want to do it. You can do it in any way you want. So for now I'll show you how we can make the wing here in ANSYS design modeler itself, and then we'll go through the steps. Okay, so okay, yeah, we can't do anything here right now. Okay, so we'll minimize this, and what we'll do is we'll go to a browser and we need data points for our airfoil. Okay, so we'll go to airfoil tools. Okay, so if we go to that website, you get the first link. Go to that, and yeah, you can find all the airfoil data here. It's very easy to do. So let's say what do we want? Let's go for 0012. I think that is the most easiest aerofoil that we can use. 12% thickness aerofoil, right? So it's a NACA 0012. There are many varieties here. We can just take any one we want. It doesn't matter. So we'll just go the most common one here. Okay. So just click on this, and there you can see this .dat file. This is your data file which contains all the data points for the 0012 aerofoil in the x and the y coordinates. There is no z coordinate here, like it remains 0 because it's a 2D figure. So just for the x and y and these points that are given here, you can draw this. Okay, so basically what we can do is we'll just copy all of this, or before that let me just okay, yeah, so there are a number of points here, right? We can decide how many data points we want for an aerofoil. So let's just go to here. Okay, so 0012. Here, okay, sorry. So we don't want camber, we don't want this 12 as a thickness. We'll go with 200 points. So we get a very good aerofoil profile. Okay, so the data points which we saw earlier, you can use that as well, but this will give a much more definite shape for our airfoil. Okay, so with that 200 points, like the number of data points you want for the airfoil, that's all, nothing else. The above one is 2412, like we will create 0012, that is fine for us, I think. Okay, and yeah, we'll close the trailing edge also. So usually this data point, what it does is it will not close the trailing edge. So if we click on this, it will close it also for us. Okay, so let's plot this, and this is our 0012 aerofoil, and let's just copy all this 200 points. Okay, copy this and then go to open a notepad and then paste it there. Okay, so we got a lot of points here. Okay, now we will just save this. We'll call it NACA 0012. Okay, and let it be in the desktop itself, it doesn't matter. Okay, now what you have to do is go to Excel. Okay, in Excel you'll have to go to open, and then you'll have to go find that in the desktop. it's a text file, so we need the text file Naka 0012. Okay, now it is asking for something like this, right? Because we are taking it from the notepad, we'll have to split those into all these individual cells, all the data points that we took. Okay, so that is pretty easy to do. You don't have to do much. After you have imported here, you can go fixed width, next, and you can see it's separated into two things. Okay, and just finish it. That's all. So you will get the values here in two different fields. Now before you go try to import this data points into ANSYS, there is a set way that you have to do this particularly. Okay, there is one set way. So what you have to do is, first of all, let me just show you how what is the format for it, and you can just follow the same format. Okay, so yeah, these details doesn't matter, like you can keep them wherever you want. Anyway, let it be here in the start itself. Now the first thing that you would want is something called the group. Okay, everything should be a hashtag. Okay, like okay, hashtag point, the number of points. Here it will be the x coordinate. Okay, here it will be the y coordinate, and then you are required to give the z coordinate because ANSYS we are going to draw it in 3D, right? So it has to be there also, and that's all. Yeah, so this these values you can just leave it there. Z is 0, so you can just give that 0, double click here, it will become 0 everywhere. It is going to be under group 1. There is not going to be any change to that, so just give group 1 and then hit, it will just be 1 1 1. Give here 1 and 2, and then click here, you will get everything till 200. Okay, yeah, so we got all the points that we require. The last point is there because it will go and join again to the first, that's why. Okay, so we'll see if there is some kind of error, we might have to delete this last point alone. So we'll see what happens, and then we'll come back here. Okay, so this is pretty simple. You just need to create this kind of format because this is what ANSYS is going to accept inside. Okay, now okay, so since this is done, we can just go file, save. I believe we will have to save it as a .txt file, so let me just go. Okay, it is already in .txt, so it's not an issue, I think. Let me just _1 just to differentiate it from the other file. Okay, so we saved it. Now we can go back to our design modeler here, and then geometry. Since our airfoil is going to be in the XY plane, click on the XY plane, click on concept, 3D curve. Okay, you can see the coordinated from coordinated files here. Yeah, so click on that, click on here, and then go to your folder location, and okay, so this will take some time. Okay, it's numeric, alphabetical. So Ezekiel MN Naka 0012 _1, that is our file. Okay, there is an error. Let me just see what is the error and then get back to you. Okay, so I found out the issue. Actually, like the naming that was in the top right, so ANSYS doesn't accept that format, but CATIA does. I don't know. So ANSYS on that top portion alone I deleted. And one more thing, since this point has to go and meet the last point, right? So what it has to do is basically in the end, instead of that 201, it has to be 0 again. So it will go meet that point again. Okay, so with that I saved this, and then I came to ANSYS again. Okay, let me just show you. I already created here. Let me just show you how I did that. Just give me a second. Delete this. Okay, so you click on the XY plane. Okay, we can look at it if you want. XY plane. Hit concept, 3D curve. Okay, and then select the aerofoil name. Okay, this is what I saved now. Okay, new. Okay, it shows a preview also, and it can be in meter, and then hit generate. Now we got the aerofoil. Okay, so this is your curve, you got the aerofoil. Now it's pretty easy from here. You know, you just need to so if it's a very rectangular wing, you can just extrude. You know the extrude option, right? So extrude it, you will get a regular wing. Okay, here we are trying to analyze a tapered wing, so it will be a slightly different thing to do. So first of all, you need to make this into a surface. So we go to concept, surface from edges, click on our curve and then hit apply. Okay, here hit apply and then hit generate. Okay, so we have a surface now. Okay, so it's a 1 meter long aerofoil, and now we have to create a tapered portion, right? So for a tapered wing, we need another tip aerofoil. So this is like your root aerofoil. You need another tip aerofoil at the other end of the wing, and then you join together by blending them together. So you get the tapered aerofoil. So for that, what we will do is we'll click on the XY plane again. We'll create a new plane. Okay, so we'll offset it and create. We'll create a new plane. Okay, so this new plane we will from this plane we will offset in the Z direction. Okay, so let me just rotate this, so we'll see. Okay, it's going this way. We need it in the other way, so we'll, let's say I don't know, we'll go with 3 meter wing. Okay, so 3 meters in the other side. Okay, now we can see a preview here, and what we are going to do is we are going to transform. The transform is basically whatever we have here, we can change it. So offset X, you will see what I mean, by 0.5. Okay, now you see what happened. So what we are doing is, one thing, we are offsetting this new plane at a length of 3 meter away from this older plane. Also in this direction, okay, we put the plane like this, so we get that tapered direction, right? So for that, so that offset can be done here itself. So transformation 1 is this offset, and transformation 2 is offset along the x-axis. Okay, so you can do 2 transformations here. If you want, you can even go to the third transformation as well, but we don't require anything. Third transformation in our comedy pathina, let's say you want to go for dihedral wing, then you can give transform offset in the y direction and then give a value so that you can have a dihedral wing also. Okay, so for now we require only a tapered one, so this is fine. And then hit this 0.5 value is again my choice. Okay, I just kept it like that. You can give any values you want, it doesn't matter. I mean, it depends on your problem. So hit generate, you will have a new plane there. Okay, so your new plane is created there. Now we just need to make our aerofoil go there. So it's pretty simple. Click on that plane. Okay, and then go to again concept, 3D curve, and in the curve, like, you can do the same process. You don't need point selection or coordinates file. Do the same process again. Naka, open. Okay, and you can see the new aerofoil there. Okay, and then you can just hit generate. Okay, now we got our aerofoil in the new plane as well. And similar to this one, we will create a surface for this also. So again, concept, surface from edges, click on that aerofoil, apply. As you can see, the thickness is 0 meters, but it's a surface of 0 meter thickness. Okay, that's why that's how it designs in design modeler. Okay, so that's surface designing, like, which has 0 thickness. Now what we have to do is, it's a tapered wing, so therefore it's not only swept, it has to the chord has to be lower. So it's a 1 meter chord here in the root, so on the tip it has to be lower than that, right? So again, it's your factor how much ever you want to decrease that. So இப்போ அது பண்ணுறதுக்கு என்ன, what you have to do is go to create body transformation, okay, scale, okay. Now you can see thing open up here. Scaling origin will be a point, body will be this new aerofoil that we have, apply, okay. Scaling factor, by how much you want to increase or decrease, okay, you can do either of those. We'll try to decrease it by 40%, okay. And then what is the base point, at which point you want to from which point you want to decrease. So I'll just hit this leading edge point, okay. I hope I hit it right. Yeah, so leading edge point at this origin point, and then I hit generate. See, now it got reduced by 40% basically, okay. So we are not interested in the edge at all, like we only require the surface, so it doesn't matter if you see the outer edge there, okay. Now next what you have to do is we need to create that wing, okay. We need to basically join them both. So to do that, you will have to click on the skin or loft option. If it was a rectangular, it's extrude, it's very easy. So for this particular thing, we'll have to select skin or loft, okay. We can select this aerofoil and not this one, okay, this aerofoil. Hold control and click, so you can select both. Click apply. Now as of now we haven't mentioned any material, so just leave it like that and then hit generate. And as you can see, we got our tapered wing, okay. So don't worry about that, that is not required for us. So we'll just, if I can click on, okay, this is blocking my view. Let me try to, okay, I can open it up. Okay, so that is not required for us. We'll just suppress that. We don't need it. Only this particular body is needed for us. Okay, even this line body also is not needed. You can suppress it if you want. Anyway, this as a solid is what we are interested in. Okay. Now, as you can see, this solid has a volume and a surface area. Everything you can, all those details you can get. Okay, so that is with respect to designing your aerofoil. Your tapered wing. Okay. Now I just gave some arbitrary values like a 1 meter long chord, and anga vandu 0.4 it got reduced, like by 40% we reduced the aerofoil's chord length, and we have done this. If you have the exact values for your aeroplane or your wing design, you can do it much more carefully. Okay, so now I'll just save this project. I think I haven't saved it. So let me just save it quickly. Answers, and we'll call it wing structural analysis. Okay. So yeah, I saved my geometry. Now I can close my design modeler. That's not required. And okay, so I think it's already 18 minutes for this particular video. So I'll let this be the part 1, and we'll go to part 2 in the next video. So see you then.